So in 2, we're going to look at systems of equations in three variables. This video is brought to you by the Lego Knight from the Black Falcons faction. Some of their earlier castle. Okay, so let's recall. If we had an equation in one variable, in other words, to the first power, we have one variable being x, with that being the first power. If we graphed it, what would it look like in one-dimensional space? Well, in this particular one, let's see, we get 2x equals -6, so x equals -3. If I were to graph this one, I would go right to -3 and draw a vertical line. Now, if this had been a y, it'd be a horizontal line. So an equation in two variables, well, I might solve this for slope-intercept form. And I might note that the slope is -2/1, that the y-intercept is 0, -5. I'd go to -5, I'd go up 2, back 1, because I'm going backwards instead of down, instead of forwards. My graph might look something like that. But what does it look like in three variables? Okay, well, that's difficult. One thing we do to graph a plane is we graph ordered triplets, and we do the intercepts. So if I make y and z 0, I could plot this point. If I make x and z 0, I could plot this point. And if I made x and y 0, I could plot this point. And then in a three-dimensional plane, now I know I'm going to screw this up because I don't know which one they do most often. I think it goes typically x, y, z in this way, but you could flip those all around in terms of which directions you're going. And what we would do here is we'd go 2 points. So here's 2, 0, 0 for that one. 0, 1 for this one, there's a point, and 0, 5 for that one. We might get something that looks sort of like this, and that would be our plane if we shaded that in. Point is, the graph of a three-dimensional object looks like a plane of some sort. So in general, we can write a quotes linear equation in as many variables as we want. It looks like this: ax1 plus bx2 plus cx3. We did x, y, and z instead of subscripts. But what we would do is make all these a, b's, and c's non-zero for each variable xn. This would be linear because they're all in the first degree. So it's x to the first power, or x subscript 1 to the first power, x subscript 2 to the first power, and so on and so forth. The problem is once we get past 3 dimensions, we don't have a visual representation of 4 dimensions. We don't quite know what that looks like. And then 5 and 6 and 7, those get out of control. So we're going to focus just on the 3 variable linear equations like this, and we're going to look at some techniques to solve them. So we had graphical techniques and algebraic techniques for solving 2. So the graph one is we just found where they crossed each other, where they intersected, or we use substitution or linear combination. There's really only one main technique we're going to look at for analytical, and that's solving for one of the variables using essentially elimination method several times and then substituting the result back in. It's kind of fun, it's kind of complicated. And then we should be clear is that there are many multiple ways of solving these, and we're going to look at one other method using matrices. So if we started with this one, note that this is in our Gauss's technique where we already have a single variable equal to a value. I would argue maybe we should have written this like x equals 9/2, but you can't argue with Gauss, right? So what we do is we now take this 9/2 and plug it back into the next equation, and we'll get y. So we have 3 times 9/2 minus 4y equals 1. Oh, man. So that's 27/2 minus 4y equals 1. So then if I subtract 27/2 from both sides, I would be doing 2/2 minus 27/2. I get -4y equals 25 halves, that's negative 25. I divide by negative 4, and I get y equals 25 eighths. Boy, that's annoying. Okay, and then we're going to plug those two values in for these equations, and we'll get z. Boy, it's like I'm totally out of space here. Here, we'll just use the back page of the previous one. So we'll do negative 5 times 9 halves plus 8 times, oh, that's wonderful, 25 eighths, plus z equals 0. It's nice that it's equal to 0 as well. So these go away. Here's our plus 25. We get negative 45 halves here, plus z equals 0. Oh, boy. What? This is 50 halves and negative 45 halves. Adding those two together, we get 5 halves. All right, and then subtracting 5 halves on both sides. There's our final answer. So let's write out what this solution looks like. It's the ordered triplet, 9 halves, comma, 25 eighths, comma, negative 5 halves. There is our solution. So we're going to give you a linear system in 3 variables where all of these might have x, y's, and z's, and we're going to have to engineer it into this form. And these are kind of the methods we can use to mess with that. We'll see an example in the next video.